Good morning, everyone. Hope all is well. Hope everyone's doing all right. As always, we wait for everybody to get connected, and then we will get going. Give a couple seconds, and we'll get rolling. All right. So, once again, good morning. Hope everybody's doing great. Everybody's doing all right. So, either yesterday or day before yesterday, I sent the videos for those last couple sections in chapter 7. Today we'll look at 8.1, and then on Monday we'll do 8.2, and that will be where we stop new content, and that's what you guys will be held responsible for. So what I'm saying here is that as far as the calendar is concerned, was it 14th, 16th? Right, Thanksgiving. 28th. I think the next week is December 5th. Yes. All right. So what we're going to do is do 8.1 today. Next class, which is at Monday, we'll do 8.2, and that's where we will stop. Excuse me, as far as new content is concerned. So that's what you will be held accountable for as far as math lab homework, everything, 8.2 and back. And then from there, when we come back from Thanksgiving, these will be review days, the 28th and the 30th. So I'm going to post final exam review for you to take a look at. Also, there will be a test generated. It'll be a 4th test. And I like to have 4 tests in there because it gives me the option of dropping the lowest test grade. So, and then the more assignments we do have, the lesser they'll weigh. So I do want to get that 4th test in there. And of course, it'll be, you'll be able to do it, at your own time. So that will be posted. But then this week right here is just all review. Wouldn't be doing anything new. We'll come to class and the floor will be open for you to ask whatever question you want to ask. This final exam, even though we're doing it through Zoom and it has to be proctored, and I'm going to give you more details on it as we get closer. You can use your notes. So what I would do is once that final exam review is posted, take a look at it. And you can generate notes according to the final exam review. You should be in a good place to knock out the test during class time. And so what's going to happen during this week, and once again, I'm going to give you more details. I'm going to give you multiple days to choose from. It'll be about 4 days that you can choose from to log on to your final exam. And you choose that, you come, enable your camera, show your ID, and then I will give you the password and you will take the test. So, yep. And but it's not one specific day because I like to give options. But this is final exam week. So, and then for each option, there will be 2 hours set aside for you to be able to complete it. Now, I'm not trying to create a test that's 2 hours long. It's just that you will have 2 hours to do it. All right. So any questions on anything I've said about any of this? And you're gonna get, once again, you're gonna get more details about it. I'm just giving you a heads up as to what we're gonna do with the rest of the semester. So everybody's okay? Oh, somebody in the chat. Okay, great. All right, so let's go ahead and do 8-1 today. And then, like I said, we can save 8-2 for next class. And get ready to close this thing out. So we have the distribution of sample means is a distribution that results when we find the means of all possible samples of a given size. And don't forget, means is another word for average. So we're looking for the average of all possible samples. And so notice when we get here, we're looking at population versus sample. You know, in statistics, they give you certain symbols that apply just to the population, certain symbols that apply just to sample. So as you get higher in mathematics, what they do is use more and more symbols so they can say less and less words. So that basically when you see these symbols, you know you're dealing with population. If you see these symbols, you know you're dealing with a sample. And just to make sure we okay what's the difference between population and a sample, you have your population or the larger body, which is your population, and a sample is just a piece of that population. So and it's just like what it sounds like. So let's say if TCC student body is the population, this class would be a sample of the student body or a sample of the population. All right, so when we look at our symbols, this is X bar. Whenever you have a letter with a bar over it, you would just say that letter bar. So that is X bar. So we have lowercase n, X bar, and lowercase s, and that represents your sample size, sample mean, and sample standard deviation. Then we have a capital N, and then this letter here is Greek letter mu. So it's Greek letter mu, and then here, this is lowercase. Let me say it like this. It's Greek letter sigma, but it's the lowercase sigma. Capital sigma looks like this. It means something different. Excuse me. And so once again, that's just a symbolism of what they mean. All right, scroll them up some. And as far as your examples, they didn't talk much about sampling error, but they did give you this box. So just in case MATLAB were to ask you a question about it, at least you know what it is. The sampling error is the error introduced because a random sample is used to estimate a population parameter. It does not include other sources of error, such as bias sampling, bad survey questions, or recording mistakes. Scrolling up. So next thing, we're looking at characteristics of the distribution of sample means. And so notice here, we're looking at sample means. The next example, we'll talk about sample proportions. So means are your averages, proportions are like percentages. So it says for any distribution of sample means, the larger the sample size, the more closely the distribution of sample means approximate a normal distribution. And normal distribution, I believe we talked about that in this class. That's when you have that bell-shaped curve. And also that normal distribution means that we can use our z-scores. So the larger sample size, this large sample size matter. And so the mean of the distribution of the sample size is going to be equal to the population mean. And then the standard deviation of the distribution of the sample means is given by this expression. We take our population standard deviation divided by the square root of our sample size. So we'll see how all of this works in this next example. All right, scrolling up. So looking at this first example, Texas has roughly 225,000 farms, more than any other state in the United States. The actual mean farm size for the state is 582 acres. Standard deviation is 150 acres. For random samples of 100 farms, find the mean and standard deviation of the distribution of sample means. What is the probability of selecting a random sample of 100 farms with a mean size greater than 600 acres? All right, so in purple, I just wrote down the given information. And then according to the symbols, you know, whenever I do a word problem, I like to write down the given information, list out the given information. So our mean, population mean is 582. Population standard deviation is 150. Now we have sample size is of 100. And then the standard deviation, not standard deviation, excuse me, the sample mean in question is 600. So notice right here, greater than 600 acres, you know, with a mean greater than 600 acres. So that's the mean in question. So that's going to be a sample mean in question. All right. So if you go back to these two bullet points here, the mean of the distribution sample is going to be equal to the population mean. So we're going to use the population mean. And then it says the standard deviation of sample mean is given by the population standard deviation over the square root of n. And so that's what we did right here. All right. So now we want to convert this to a z-score with the given information that we have and that piece that we calculated. So it's a sample mean minus the population mean divided by the standard deviation. So the sample mean in question is 600. The population mean is going to be 582. and that standard deviation is 15. All right, so doing our calculation, 600 minus 582 divided by 15 is 1.20. So we're always going to round to 2 decimal places whenever we're calculating our z-scores. All right. So now they say go to table A1. That's in the back of your book. So can I go into that page? Anybody? Hold on. Well, we're coming back to it anyway. I just want to show you how this table looks. And of course, it went out. Hold on 1 second. There we go. And I'm going to send you this table. There are 2 pages. You have the negative side. So if you have a negative z-score, you go to the first page. And then if you have a positive z-score, you go to the second page. All right. So we have a positive z-score. We have z equal to 1.20. So magnify this some. So what's going to happen? Oh, okay. So what's going to happen is on this left column, you're looking for the 1.2, and then the 0 is going to be up here. That this right value, the rightmost digit will be up here. So if this was 1.125, then I will go to this 5 right here. Okay. But we have 1.20. So I found 1.2 over here, which is right here. 0 is right here. And then where they meet is the value that I'm pulling from the chart. So it's 0.8849. Okay. So just make sure we're clear on how to read the chart. Let's say if my z-score was 2.34. So the 2.3, I'm going to this left column, and the 4 is going to be up here, you know, at that top row. So let's say 2.3 right there. 2.3 is right here, 4 is right here, and where they meet is the value that I'm pulling from the chart. So it's 0.9904. All right. So before we go back to the notes and talk about what the chart value actually means, is everybody okay with how to read the chart? How you pull the value from the chart? All right, sounds good. And of course, if any questions pop up, always feel free to ask, you know, later on. So take note of this so we don't have to come back to the chart. Notice it says the z-score is right here, and then they have this shaded part to the left. So left of is always going to represent less than. And what this is telling us is that the chart value that we pull, and I wrote this in the notes, but I'm just showing you the visual that they're giving us, that the chart value that we pull will always represent less than. And so if you were to go up here to the negative side, it does the same thing. Z-scores right here in the shades to the left. So this chart value that we pull will always represent less than. And like I said, I wrote that in the notes, but I just wanted to show you what they, you know, the visual. All right. So there we go. This is the chart value. We just pulled 0.8849. Once again, the chart value always represents less than. All right. So if I were to take that chart value, what the chart value means is that the probability of selecting a sample mean or a sample with this. I wrote that twice. I messed it up. So let me erase the double. All right. All right, so the probability of selecting a sample with a mean less than 600 acres is about 0.849. All right. So now you always have to pay attention to the wording in your problem. Our problem didn't ask for less than, it actually asked for greater than. So to find greater than, you're going to subtract the chart value from 1. And so that's always going to be the case. You know, once again, the chart gives you what's to the left. So if you want to know what's to the right of the z-score, you have to subtract your chart value from 1. Everything under the curve is equal to 1. And so that's why you do that. Oh, so you've been moving ahead? Okay, yeah. So the probability of selecting a sample with a mean greater than, which is what we're looking for, greater than 600 acres is about 0.1151. So that's our actual answer. I just wanted to make sure we had clarity on what the chart value actually gives us. But our actual answer is the greater than one. That's the one we were looking for. So that 0.8849 represents less than our chart, our z-score. Remember that z-score represents the 600 acres. And then the 0.1151 represents greater than, which is the answer we were looking for. All right, questions before we move to the next piece. All right, so the standard notation for working with proportions, once again, lowercase n is sample size, capital N is the population size. Then we have what we call here, whenever you have that symbol. Yeah, that's p hat. So your sample proportion is represented by p hat. It's just that p with that little triangle with the base missing. And then lowercase p, just a regular p, is the population proportion. All right. So similarly, with what we did with the last one, we have distribution of sample proportions is the distribution that results when we find the proportions for all possible samples of a given size. So the larger the sample size, the more closely the distribution of sample proportions approximates a normal distribution. So same thing, a large sample size matter for us, and that takes us to the large to that normal distribution, which allows us to use the z-scores and z-scores charts. So the mean of the distribution of the sample proportions is equal to population proportion. So same type of deal with that. And then here the standard deviation we'll calculate by doing the square root of P times 1 minus P over N. All right, so I scroll up. All right, so here, consider the distribution of the sample proportions shown in figure 8.5. Let me see, 8.5, missed that part. All right, compute the sample proportion P hat for the sample. How far does it lie from the population mean? What is the probability of selecting another sample with a proportion greater than the one you selected? All right, so we go. Okay, that's fine. Let's see. All right, is everybody done with that orange box? All right, so let me erase this. All right, so let's look at the first thing they ask for us, ask of us. It says compute. Let's say compute P hat. All right. So here. Okay, so we're going to compute P hat. That's what they asked us in this first statement right here after they gave us the set. Now, we're looking for the proportion of Y's, and that was discussed in the previous paragraph. Try not to give you guys unnecessary things to write. And so I went straight to the example, but there were some other things discussed in the previous paragraph that some of it was relevant, like the fact that they wanted us to go to Y's, but there a lot of stuff wasn't for this example. All right, so let's compute P hat. Now to find P hat, you're always going to do X over N. X is your characteristic, N is your sample size. We know as far as these responses, let me say it like this. I might as well take the number of Y's is the characteristic we're looking at here. And then here is the sample size. And we know that we have 32 responses for that sample size. And then we would count the number of Ys. All right, just making sure. So it's 24. All right, 24 Ys. What's the number of? All right, so the next thing they ask us is how far does it lie from the population mean? So the first thing we need to do is do P times 1 minus P divided by the square root of N. Not square root, square root of P times 1 minus P divided by N. And our P, let me do this. We got that from the other problem. So when you get a problem in math lab, of course, they'll give you all of it in that problem, just like in the previous example we have. So, but in this case, oh, drop my pen. Remember, they even said right here, go reference the figure and everything like that. So they had this stuff set up in another paragraph. So in another paragraph, and that P is 0.6, if I'm not mistaken. Yeah. So now we can calculate. So it's 0.6, 1 minus 0.6 divided by 32. And of course, make sure you know how to use your calculator and be able to calculate these things. And if you don't have a calculator, you can put all of this in here like this. And you would go step by step using your order of operations. Let's see, 0.6 times 0.94. And you can take, hold up, is it 0.06? Oh, not 0.06, it's 0.6. So it should be 0.4. I was thinking 0.06 times 0.6. So just walking it through just in case you didn't have that type of calculator, and divide that by 32. 0.0075 to the square root of that. Zero 8660. Yeah. So since that's 0, stop it right there. All right, questions on that part? How far does it lie from the population mean? We haven't gotten there yet, but we got to convert it to a z-score. So we're going to use the sample proportion minus the population proportion divided by the standard deviation. And going back, we got our population proportion. I mean, a population proportion, sample proportion, which was that 0.75 minus the population proportion, which is 0.6 divided by 0.0866. All right, so that 0.0866, evidently I was too accurate. They went to 0.09 in the book, and I'm trying to stick with what the book gave you. So they're probably going to want, and they should guide you this way in MATLAB. It should say 2 decimal places, you know, and then they want you to use that, because using 0.0866 will give you a different z-score. Even though it's more accurate, I'm going off of what they did here, and that's what the book is going to hold you to. That's what MATLAB is going to be programmed for. So doing it this way will give you 1.67. And remember, we always round into 2 decimal places. All right, so once you have your z-score, you go to table A1. Hold on, did I say table value or chart value last time? I think I'm used to saying chart. Yeah, I did say chart value. Probably need to be consistent and say table value, since your book keeps saying table. Of course, that's just notes. It's not really a big deal, but so if we were to go to the table, the other book that we had used to say chart. So that's why I'm just doing chart. Looking at 1.67. So 1.6 is right here, 7 is up here. And we're looking at 0.9525. All right. So once again, that represents less than for us. Let's see. Oh, I didn't mention this part. How far does it lie from the mean? So what were we talking about? The sample proportion. All right, so if they were to ask you how far it is from the mean, once you convert to a z-score, that's what your z-scores represent, how far data value is from the mean in terms of standard deviations. So 1.67 is positive 1.67. Remember, I did mention that it is possible for your z-score to be negative. So we have positive 1.67. So this means that the sample proportion lies 1.67 standard deviations above the mean. If it was negative 1.67, the whole statement would be the same, except it will be below the mean. So it will be the sample proportion lies 1.67 standard deviations below the mean if that was negative. Right. Questions or anything before we close out this problem? Got to finish it off with our last statement. All right, so that 0.9525, remember, every time we pull up a value from the table, excuse me, from the table, it represents less than. We want greater than. So since we want greater than, it'll be 1 minus 0.9525. 0.475, not mistaken. All right, so let me write this out just in case you see something like this in MATLAB. All right, so we did the 1 minus the 0.9525, which is 0.0475. That gives us our greater than. So one statement that will help us with our conclusion is in red. The probability of selecting another sample with a proportion greater than the one we selected is about 0.0475. So that's the exact value you pull from the chart. Now, if they were to give you another type of statement, like the one in blue, this is how you make sure that you have the right answer. So it says, in other words, if we were to select 100 random samples of 32 responses, we should expect about 5 samples with a higher proportion than the samples we selected. So where they got that about 5 from is by taking the 100 random samples and multiplying it times the probability of 0.0475. And so that, so that gives you 4.75, which is about 5. And so you would always take this number and multiply it times that proportion that you got from the chart. So if it was 1,000, you would multiply 1,000 times that will give you 47.5. So they should have right here about 48 because it'd be 47.5. So once again, you would just multiply this number times that number, and this number should be the result, or close to it. Rounding that number should be the result. All right. Questions. Everybody good up to this point? Okay, so that's 8-1. They gave you those 2 examples and those 2 types of problems to work with. So try it out, see if you have any issues with doing them. And then from there, we can, like I said, we're gonna have a whole week just dedicated to answering questions. Of course, my office hours will still be available as well. And then next class, we'll do 8-2. Let's make that clear. Yeah, we'll do 8-2. And then get ready to close it out. All right, so any questions before we close out today? All right. So, did I hit mute? Okay, so with that being said, you guys have a great one, have a great weekend, be safe, and I will see you on Monday.
Have a good day.
Thanks, you do the same. Take care. Thanks, you do the same, Brady.
Can you hear me?
Yes.
Thank you. Have a good day.
Apologize for not being here the last, I think it was 3 days, because I've just been utterly sick, or was utterly sick.